Hello viewers, now we're going to discuss about an important chapter of class 11, that is quadratic equation. From your earlier knowledge, you know what is quadratic equation. Ax square plus bx plus c is a polynomial of degree 2 and maximum two values of x will satisfy this polynomial. If I take that values as alpha and beta, and we are able to factorize this one, and we can write ax square plus bx plus c in the form a into x minus alpha into x minus beta. Here alpha and beta are called zeros of a polynomial. Zeros of a polynomial. Similarly, if you take, when you put up that x, this polynomial x square plus bx plus c is equal to 0, then it forms a quadratic equation. So a into x minus alpha and x minus beta is equals to 0 gives x is equals to alpha and x is equals to beta as roots of the equation. And this alpha and beta, the maximum roots. Maybe a quadratic equation has no roots. Suppose x square plus 1 is equals to 0. So if we solve this, x square is equals to minus 1. So this implies x has no real roots. Later on we'll discuss about this type of equations. Now, the roots of the quadratic equation, if we solve x square plus bx plus c is equal to 0, then we get the roots as alpha is equals to minus b plus root over b square minus 4ac by 2a, or we can write minus b plus root d by 2a. Similarly here, beta is equal to minus b, instead of plus now it is minus root over b square minus 4ac whole by 2a. So minus b minus root d by 2a. Here d is called discriminant. And it determined the nature of the roots. Nature of the roots is determined by d. How? Now look at this table. This is our discriminant. Here there are three possibilities. D may be positive, D may be 0, and D may be negative. If D is positive, we are getting two forms. One, if D is a perfect square, then roots are real, distinct, and rational number. Suppose we are taking an equation x square minus 5x plus 6 is equals to 0. So here a is equals to 1, b equals to minus 5, and c is equals to 6. So d is equals to minus 5, that is b square, minus 4 into 1 into 6. So it is coming 25 minus 24, and this becomes 1, and 1 is a perfect square. So here, if you solve this one, the roots will be real, distinct, and a rational number. So if you put this, so we'll get the value x is equals to minus b plus minus root over d by 2a. So there, if you put x is equals to this, so now b is minus 5, so minus of minus 5. Now the value of d is 1, so root 1 by 2 and a also 1, so coming 5 plus minus 1 whole by 2. So 5 plus 1 by 2 and 5 minus 1 by 2 gives us x is equals to 5 plus 1 6 by 2, that is 3, and x is equals to 5 minus 1 by is 4, 4 by 2 is 2. So here the numbers are, or roots are, a rational number. Now, what happens when d is not a perfect square? So if d is not a perfect square, then roots are real, distinct or different, but irrational number. So now here we'll take also an example. Suppose we have an equation like 2x square minus 6x plus 3 is equals to 0. So here also d is equals to b square, that is minus 6 whole square, 4ac, 4 into 2 into 3. So that is 36 minus 4 2s are 8, 3s are 24 is equals to 12. So it is positive, but it is not a perfect square. So here x is equals to minus b root d by 2a. In that question, if you write values, so b is minus 6, so this becomes 6 plus minus root over 12 divided by 2, and a is 2, so it becomes 4. So 3 plus minus, not root 12, this is 2 root 3. Okay, so now taking 2 common, it is 3 plus minus root 3 by 4. So therefore x is equals to, after cancelling 2, 3 plus root 3 by 2. Another x is equals to 3 minus root 3 whole by 2. So these numbers are irrational numbers. So here the roots are coming irrational. Now roots are, if d is equals to 0, then roots will be real and equal. In that case, actually, the x is equals to minus b, by 2a, because in that case d is 0. So that's why the other part will not be exist. So here we'll get x equals to minus b by 2a. Now we are getting an equation x square minus 2x plus 1 is equals to 0. So here d minus 4. So 4 minus 4 is 0. So here x is equals to as minus b by 2a. So putting b as minus of minus 2, so 2 by 2 is equals to 1. So both the roots are 1 and 1. The last one, if roots are not, d is negative. So we are taking an example as 4x square minus 5x plus 3 is equals to 0. If we solve this one to get the value of d, we are getting minus b b square is 25, that is 5 square. Four into 4 into 3, so 25 minus 48. So this is equals to minus 23, which is negative. So roots are not real. Here you can write x is equals to 5 plus minus root over, as d is minus 23, you write minus 23 by 2 4s are 8. So here two roots are not real, they are complex numbers. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.